Hi, and welcome to this STAIR Tailored. I'm Erica Mason from the University of Missouri, and today we're going to be talking about part 2 of a 4-part series about multiplying linear expressions. Today's video is about how to multiply how to multiply expressions using positive terms. Before we get started, let's talk a little bit about the underlying idea of using multiple representations. So in her 2017 article, Tricia Strickland talks about the importance of using a concrete, representational, abstract, integrated model, or CRA-I, which is similar to this idea, concrete, pictorial, abstract. Those are just two different ways to say the same thing. The integrated aspect, though, that Strickland highlights in her article is the idea that of these representational types, there really isn't a hierarchy. That is, concrete representations aren't necessarily lower than abstract representations, but instead think of them as just tools, multiple tools that students can use to make sense of mathematics. This is especially important for students who have mathematics difficulty or disabilities, because not only does it increase the opportunities for them to connect to concrete materials and representations and visual or pictorial representations, but it also then gives them a variety of ways to approach different problems. In this particular lesson that we're going to talk about, multiplying expressions using positive terms, we introduce the idea of vocabulary development as a precursor activity before students actually start using the manipulatives. There are multiple ways to approach vocabulary development. So first, you might just start by asking students what they know about these words and terms. Where have they heard them before, and how would they define them now? You can then transition into an activity where you introduce, for example, a 4-square model, where you give students the term, you provide a definition, you provide an example and a non-example. And you can work with students to do this so that they can develop a deeper understanding about what these terms mean. The other thing then is, as you transition into actually using the manipulatives and working through the mathematics, you're going to find that students have opportunities to use these terms in authentic contexts. That's also going to continue to help them deepen their understanding about what these terms mean. Okay, we're going to turn now to the document camera, and we're going to look at how this actually looks with some algebra blocks. So to model how we're going to multiply linear expressions, we're going to use the example x plus 4 times x plus 2. So there's a couple things to note before we get started. You're going to end up being able to talk about where the distributive property shows up in this representation. So we'll talk about that in a minute. You're also introducing students to the idea of x times x, because we're getting into multiplying two variables. So you might have some students, when they start trying to model this, this problem, you might have them try to represent what is x times x. And students might be tempted to say, well, that's 2x. So you would encourage students to then model what that looks like using this corner piece and these algebra blocks. So x times x equals 2x, question mark. If students create this representation, this really fosters a great conversation and an opportunity to remind students of a couple things. That these blocks here represent the factors of the problem, and they really establish the boundaries or the values of those terms. Because these are both variables and we don't know the exact value of that term just yet, it's easy to think that then inside here, or the product, can be any number. But instead, you're going to point out to students again that you're always trying to make sure that you're in the boundaries of these terms. If you say x times x is 2x, you are definitely within the term here, or the boundary, but then this is left blank. So what do you make of that? I think this, again, is a really great opportunity to talk to students about what x times x means. It means x times itself, really, right? So that then means that x times x is really x squared. So let's go ahead and practice modeling what this expression is going to look like. So first, before I start actually multiplying, I'm going to represent the two terms on either side of the corner piece. So if I have x plus 4, that's x, the x bar, and then 4 integer constants here. And then if I have x plus 2, I have the x variable there, plus the 2 integer constants here. And now we're ready to multiply. And here's where you're going to have a really rich opportunity to talk to students about the distributive property. If students have had any exposure to the distributive property in a more traditional way, they might remember that that means that every term from both terms get multiplied by the terms in the other term. So that's much easier to see in this representation. So first we're going to start by multiplying x times x, which we just established was x squared. Then we're going to say this x times 2 is 2 x's. Oops. Now, coming over here, we're going to multiply these 4 integer constants by this x, which will be 4x. And then lastly, we look at these integer constants. We have 4 times 2, which is 8. As students are creating this representation, you can remind them that, again, the factors on either side of the corner piece represent the boundaries of the problem. That is, when they get their final product, they should have a rectangle that fits within the same boundaries. If you have extra blocks here or here, that again gives you a great opportunity to talk to students about the relationships that they're trying to model. Before moving on, you should ask students to not only look at this problem and try to make sense of it, but then to represent it in another way. Here is where you could ask students to actually sketch this very representation. So they would draw their own corner piece and then draw each of these manipulatives. They would draw their own x bars, their own integer constants, and their own x squared piece. Once students have had a chance to sketch this representation, you might then help them read the product here and then translate these manipulatives or their drawing into abstract notation. So they might generate something like this. And you can help them see where each of these terms is in this representation. Some students might even break out this 4x and this 2x here first before moving to the 6x term, and that's totally fine. At this point, students will have had the opportunity to engage with all 3 types of representations: concrete, pictorial, and abstract. It's totally normal for students to feel drawn to a particular representation that makes the most mathematical sense to them. So if a student decides to skip the direct modeling aspect and move straight to the sketch, that's perfectly fine and expected. The benefit here, again, is that students have the chance to see the mathematics. They see the multiplicative relationship modeled clearly and can start to make sense of what's going on underneath these expressions. Thanks for watching the STAIR Tailored. Make sure to check out our next video in this 4-part series. The next one is about multiplying positive and negative terms when trying to multiply linear expressions.